So I'll try to explain the curve fast. Okay, so that's the left atrium pushing blood to the left ventricle, then the aorta, and the cycle keeps repeating itself. That's the cardiac cycle. Okay, the cardiac cycle starts first of all with the electrical activity of the heart, the automaticity from the SA node and the ECG, and that will start with that. But before that, we have to know what the curves had. The curve has four pressure changes: the left atrium, the left ventricle, and the right atrium, and the aortic pressure. Okay, and two things that are the sounds and the electricity, and one volume, which is the left ventricular volume. Okay, so let's see all of that now. As we said, it all starts with with the ECG. The ECG starts with the P wave or the atrial contraction and the QRS, and the T wave, which is the atrial QRS, and then the T wave, which is the ventricular relaxation or repolarization. The P wave corresponds to atrial contraction. Okay, so let's start with the atrium, left atrium. Okay, the left atrial contraction, the atrial contraction will increases the pressure in the left atrium because it's contracting, so the pressure will increase, and then it will start to relax, emptying the blood. And then after relaxation, if it relaxes without closing a valve, the blood will flow back because the pressure is low there. Okay, so we don't need that. So there is a valve here that needs to close, which is the mitral valve. That's the mitral valve closure. Okay, and the mitral valve closure creates what sound? S1. Okay, S1. So the atrial contraction and then relaxation, and during this period the atria is emptying blood, so it's the mitral valve is open. And there is a general rule that says whenever two chambers or any areas, any rooms, when they share an open door or an open valve, then they are considered one, and the pressure in all this area will be the same. So how do we apply that on the curve? The lines will be on top of each other, which are here the left atrium, and the left ventricle. They share the same pressure because the valve between them are open. Then the ventricular contraction comes. The ventricular contraction, then starts the relaxation, ventricular relaxation. Okay, and during this period, this is the mitral valve is closed. The ventricle will start contracting until reaching a point where the ventricular pressure is more than the aortic pressure, and then the aortic pressure the aortic valve will open. That's the aortic valve opening. And then, as we said, whenever there is a shared valve or a shared open valve, the pressure will be the same. Okay, then the pressure of the aorta will continue, and the pressure will go down. The left ventricle relaxation will start, and the left ventricle pressure will go down. And if it went below the aorta, the blood will rush back, and we don't want that. So a valve here should be closed, which is the aortic valve. And as we said, the blood will push back, creating what? A diacritic notch. Okay, so it will create a diacritic notch. And the same method applies everywhere. When the mitral valve closes, the pressure will flow back, creating what? Creating a C wave. Okay, so that's a C wave. That's an A wave atrial contraction. That's a C wave, which is due to contraction of the left ventricle, pushing blood against cross-track mitral valve, creating a slight increase in pressure in the left atrium. Okay, so let's continue with the curve. Then the atria will relax and starts collecting blood from the system or from the preload until it reaches a point where the atrial pressure is about to increase more than the ventricular pressure, and then the atria will start to empty and the mitral valve will open. Here the mitral valve will open, mitral opening. Okay, and as we said, here the atria will relax, so that's the X wave for atrial relaxation, and then the atria will collect blood until it comes here to empty blood. That's the Y wave, which is the atrial emptying. Empty, relax. Okay, so what else do we have? Just delete these. Okay, now we finished the atrial curve, the left ventricular curve, the aortic curve. Let's see the heart sounds. Okay, the heart sounds starts with the S1 for closure of the mitral valve, then the aortic valve will open, and here the aortic valve will close back, creating a second heart sound, which is the S2. Okay, and after the S2, that's the second heart sound, the S2. Okay, after the S2 is due to closure of the aortic valve. There is an S3 and an S4. S4 is more closer to the S1. That's the S4. Why does S3 happen, or when does it happen? So during ventricular relaxation, we have 3 periods of ventricular relaxation. The first one and the last one, that's the rapid relaxation, rapid filling. Okay, rapid filling. That's the late filling. During this period, the pressure gradient drives the blood from the left atria to the left ventricle very fast. So there happens a turbulence when there is increase in blood. Okay, the S3 will increase. The turbulence here will create that S3. So S3 in the early diastolic phase, which is closer to the S2, but here that's the late diastolic phase. The late diastolic phase, what happens? So it's late diastolic, so the ventricle is almost filled with blood. That's the early phase, that's the early diastolic, then the mid diastolic, then the late diastolic. So the ventricle is almost full of blood, so the blood will start pushing on the wall of the ventricle. So if it is stiff, it will create that S4 sound. It will be heard louder. Okay, so we finished with the heart sounds. Hope you got them. I'm sorry that I'm fast, but I don't want to make it boring. Okay, so the S3, we said the S3 comes after the S4. It's due to rapid filling, increases in conditions where there is increase in the left ventricle or the left heart blood, like mitral regurg, I guess, or aortic regurg, and the S4 increase in condition where there is a stiffness of the heart, so pericarditis, I guess, and that. Okay, now we finish with the sound. What else do we have in the curve? The left ventricular volume. So the left ventricular volume will be very easy. Why? Because here the left ventricle will start to collect some blood, and then here will start to contract, emptying the blood, and then it will start to collect blood again. So that's the left ventricular volume. What else? We said the left atrium, the right atrium. So the right atrium is just like the left atrium. It will start to contract, increases in pressure, and then after that, what happens, as we said here, and here the back of flow, the tricuspid valve will open, and the flow from the right ventricle will back to the left ventricle, creating a C wave. That's the A wave of a right atrial contraction, and then a C wave, and then it will continue just like the left atrium relaxes and then emptying. What else? Okay, let's discuss the pathologies that will happen or that will come in the questions. So, if there was a sound that's closer to the S2, then it is the S3, like it will be early diastolic. Late diastolic, it will be the S4, and the case will make it clear. If there was a volume overload, then it's S3. Okay, let's see some pathologies. Okay, so that's the curve. I يعني from doing questions, or يعني when you get exposed to this curve a lot, you'll notice something. So as we said, here and here and here, the lines should be on top of each other. Why? Because the valves are open. Okay, the valves are open and they should share the same pressure. But what happens if the lines are separated? Like if you saw the curve, and this side is like that, and the ventricular, for example, or it was like that and the ventricle was like that, there was a space here where it shouldn't be, then you'll know it's stenosis. Stenosis of what valve? The valve that's supposed to open here, which is the mitral. Okay, so when there is a space, that's how I remember it. With space there is stenosis, and here too, space, stenosis. Okay, if it was here, it will be here too. So I guess it's only the mitral stenosis that can present with this case. Okay, what if the space was here? Then it's stenosis space equals stenosis. Stenosis of which valve? The aortic. Okay, the aortic stenosis. What about, what else can be present? The regurgitation, for example. So let me remember. Okay, let's remember it. Yeah, the regurgitation will be, it's a problem with aortic valve closure. So there will no be diacritic notch, because that notch is supposed to be due to back of blood against a closed valve. So there is no actual closure of the valve. So there will no be the diacritic notch. So it will the curve will be like that, and there will not be an actual return of pressure. So the pressure will be like that, because the pressure, the blood will go backwards, so it will be a bit lower. That's the aortic regurg. What about the mitral regurg? The same thing. Mitral regurg, the mitral won't close that, so the C wave will not be very prominent, I guess, and the curve will be a little bit down. I'm not sure about this one, not to confuse you, but I'm sure about everything else. What else can be present with that curve? I guess we covered it all. I hope it was simple. Inshallah, yani. X descent, atrial exit, downward displacement of closed tricuspid valve. Try to read it, and that's how I remember the V wave. It's the atrial velling, like filling. So velling, atrial velling. There's the V wave, which is this one. Okay, and what else? Diacritic notch. We didn't forget anything, alhamdulillah. The A wave, C wave, X wave. So it's very easy, and when you understand it, it becomes very easy. Hope this video was helpful, and sorry I took time and tried to make the subscription. I already got it, but yeah, you have problems with it.